Okay, going forwards, the first presentation today is going to be a nice overview conducted by Parlin Sagar, who we do not need to introduce for the 20th time or whatever it is. But every about a year and a half, there is a very good conference that's called the Winter Wind Conference, held in Sweden. Brings in a bunch of people that look at issues dealing with wind turbines operation in Arctic and cold climates. The meeting was just held about a month ago, and Per Lundsager went and attended, and so it's going to give us a quick overview of the results of that conference. Per.
Thank you. That's right, I went there actually on behalf of WIDAC because it was part of my contract with WIDAC that I went there and saw what was going on. There it was, yeah. Excuse me, do I have any cold climate background? Not a lot. In 1993, in my time as an independent consultant, I was project manager for a Danish project in Greenland, looking at the possible application of wind energy in Greenland. And here the main issues were not very much cold climate related. It was more related to wind diesel and extreme wind. The project actually pointed towards renewable energy potential in both townships and especially actually in remote communities. But in my study I came up with, if I remember correctly, a lifetime cost of energy from wind of 62.62 of our local currency, 0.67, and utilities claimed that they could produce diesel power at 0.62, so that was so our recommendations were not followed. And today Greenland relies completely almost on hydropower, which is why we have the old saying in the renewable energy circles: if there's water around, forget about wind. If there's wind about, forget about solar. They forgot about wind. But there is a distant offspring of this project. In 2010 there was a 6 kilowatt proven wind turbine installed and connected to the diesel grid in one of the settlements I visited, called the Fangok. And very interesting, they didn't know about my study, but independently of each other, we put the cross where the wind turbine should be on exactly the same site. So at least we agree on that. Furthermore, I was one of the founding fathers, or rather the correct word is parents, since the original driving force was a woman from Finland, of the International Energy Agreement on wind energy, and Annex number 19, which deals with wind energy in cold climate. Eventually Denmark decided, not by my goodwill, but Denmark decided to leave the annex because at that time the wind industry in Denmark expressed a lack of interest in cold climate issues. They said the market was too small. So that's my background for this. Yes. Winter wind in brief. In italics I write what the conference organizers, which is Swedish Wind Energy Association, they've seen a growing interest in wind power, cold climate and icing conditions, and many companies now offer technical solutions for this big and upcoming market. And there were 40 presentations in English. In a parallel session there was a similar number in Swedish. There were 30 posters, 25 exhibitors, typically equipment and service providers, and altogether 270 delegates from a number of countries. Most of the presentations were dealing with icing forecast and how to deal with icing. But there was a very interesting final roundtable with presentations with major wind. I'll come back to that. Okay. There was, at the end of the conference, there was a summary of what was going on in the conference by Jos Berskens, another old elephant in the business from Holland. And he made a presentations which you can see on the Winterwind homepage below here. But he said that in the conference you could look at the five most significant research needs. It was anti-icing and de-icing, number one. The second one, what was the condition for icing, icing probability, and cold climate resistant measurement equipment. Third priority, hidden energy losses because of icing, ice loads, and loss of aerodynamics. And not to forget operation, maintenance, and repair. The fourth most important issue was feedback from real operating experience to designers, and that also we're talking with Vidak a lot about how to provide that. And then the fifth priority was update on market potential. There was only 3 presentations dealing with what's happening on the grid. And what did I especially notice? I noticed a presentation by Gamani Lloyd, who issued a technical note on cold climate. And the first paragraph here deals with what do they consider to be normal operating temperatures. And I noticed that the low one is survival temperature minus 20 centigrades, maximum for 50, that's not so relevant for here. And the technical note defines cold climate with a minimum 9 days below 20 degrees centigrade, and that operational turbine should be able to operate below 15 degrees centigrade. And interesting enough, the Gamani Lloyd allows the manufacturers to define the 3 temperatures and the air density. To me, that came across as a not very strong requirement. And to put that in perspective, if I remember correctly, and I may not, but the 65 kilowatt bonus wind turbine that was erected in Kuujjuaq in Canada many years ago, I know it was specified and designed for minus 45 degrees centigrade. I don't know if it was, I don't think it was certified, but I seem to remember, and I remember being told that the first 2 weeks it actually operated in minus 65 degrees. And I'm told it was not standing, it was actually operating. So in view of that, I think that Gamani Lloyd technical note is not a very strong thing. It was mentioned that typical annual icing downtime was 10 to 28%, 10 to 28% of the time, and that was a finished presentation. And the thing that made people jump in the seat was that study made in the framework of this Annex 19 estimates that the international market for cold climate is 4,000 to 5,000 megawatt a year, and that's similar to estimated offshore market. And my conclusion is that maybe that's why the big wind energy industry now becomes interested in this. There was a long discussion, so blade heating, does it pay to heat the blades? There's only one of the significant wind turbine manufacturers today that actually offer blade heating, including the necessary warranties on the turbines. That's Enercon. And there was a report from 2 Enercon E82 tested in Switzerland. And the system works the way that when ice occurrence is detected, the turbine stops for 3 hours. The blade heating system with using hot air in the blades is started, and then the wind turbines restart automatically when that is done. And they distinguish, very new for me, between meteorological in contrast to instrumental icing. you can have meteorological conditions that are encouraging icing, but the effect of that icing coming in that period comes on the instrument equipment, and there the ice will stay much longer. So even if you have a period of only 10 days with meteorological icing conditions, your equipment may be disturbed by the ice for 40 days. The study, the measurements on the Enercon turbine said that annual production loss without blade heating would be about 10%. And with the blade heating, you would recover 7% of that loss. The energy needed for the blade heating would be only about 0.4% of the annual production. So there's a benefit from blade heating. The production loss of about 3% remains because the turbines are stopped during the blade heating. And they said, which is not difficult to understand, that these results are very site-specific. What else did I notice? There was very little talk about isolated systems or wind diesel systems and turbines related for that size of operation. Most of the talk were about utility grade and offshore machinery. But for those large utility grade turbines, the manufacturers rushed actually to promise to develop and offer blade heating systems during this final roundtable. But one thing that was very clear, they are what you would safely call paranoid about releasing any technical details to their competitors. And since the competitors were all collected around the round table, they mainly gave promises to what they are going to do, not how they are going to do it. The Finnish production manufacturer Windwind estimated that 1.95% of the power production would be needed for their solution for blade heating. Nordic Scandinavia has developed a system together with a power utility in a system that was developed November last year, and all he said that it was easy to heat the system, but it was very difficult to control the heating process. Vestas made it clear that they are working on de-icing techniques, and they will eventually provide it as an option. Again, no technical details. Siemens say that ice is more of a problem than low temperature. And that, I think, is interesting coming from those who provided the Kuujjuaq turbine. They will provide blade heating not as an add-on option. You can order it when you order the wind turbine, and then the blade heating system will be integrated in the factory. And they expect a second generation to be ready in 2012. And they actually said that their system is based on electrical heating mesh in the blades. So what's my conclusion of the winter wind? It was well organized and well operated. And I think it was worthwhile attending it for the same reason that Ian named. Here we have a collection of people in the business dealing with cold climate issues. Was it relevant for wind diesel in Alaska and other cold climate places? With respect to these icing issues, yes, it was. With respect to wind diesel and other machinery, not very relevant, because that was not dealt with. Although, excuse me, of course, the developments in blade heating and so on, and certification will eventually become relevant. The conference program and all the presentation can be downloaded from the homepage, and I recommend all of you who have an interest in that to go in and look at there were many good and interesting presentations. As I say below, there's a lot of good info, but beware not to be caught up in the Swedish stuff. You won't understand what they say. So that's it.
Any questions for Per? questions? No questions?
Perfect presentation.
A perfect. Oh, wait. I'm not sure if that's on, Kat, so just check it. Ah. So, there.
In thinking about the blade heating with the mesh, when some of the manufacturers detected there's ice, they would go ahead to go ahead and put heat into the blades. Could that not be a low-level mesh heater on all the time in cold climates? You wouldn't maybe not lose that much, I don't know.
That's a good question.
Do you want
Sorry, yeah. That's a good question which I'm not able to answer for the reason I told you about that the manufacturers there were not willing to discuss the technical details of their solutions. So I cannot answer that. It may be a way to deal with it.
If I may comment rather than question, at Whitehorse, dealing with icing and problems with control, we were heating the leading edges of the blade, and in the first year we took the control out and simply turned these leading edge heaters on and let them on all winter. So, and power density, even a relatively low power density is effective. And you'll see more of that later. We have a presentation.
Okay.
Was there any discussion of any aftermarket ice mitigation technologies, or is everything pretty much done in the factory with the larger scale wind turbines?
Siemens said that nothing will be after they do it in the factory. The other manufacturers were not specific about that. I know about a Finnish initiative of blade heating of a system that was supposed to be added on later, but that has so far not come into production.
There are a couple of other. Kelly Aerospace has an aftermarket product. Also, there's a couple of ice-phobic coatings that you can apply in an aftermarket case. Right, but the Kelly Aerospace, they're just testing it now, and the phobic ones, you can put them on, but the long-term longevity of the coatings on the leading edge of the blade is pretty questionable. So there's stuff that you can get in the aftermarket case. We'll see how well it takes.
Thanks for that. It reminds me that at the conference it was agreed that it actually helps painting the blades black. Not an awful lot, but you can actually see a positive effect of it.
I wonder if you have any knowledge of manufacturers using nanoporous material and electrical pulses as they do on dust on solar photovoltaic panels.
I'm sorry, say that again, please.
I wonder if you have any knowledge of manufacturers using nanoporous materials and electrical pulses as they do on solar photovoltaic panels to get rid of dust.
It's very close to the chest, so if it could be that they are looking at that and they just wouldn't tell us. Great. Thank you very much, Per.